Hi guys, I hope you're good since last video. Have a break, have a rest. Even if we had seen the different rules about borrowing and owning, for example, we said from one variable you can make several references of it, or from one mutable variable you can make several mutable references of it. We talked about lifetime, and I have agreed that we are going to postpone it for later on. Well, this later on is now. In this video, I'm going to focus on Rust's lifetimes. The first part will be explaining it and answering to some questions. In the second part, we will be doing the hands-on with some examples. Please like and subscribe. Thank you for your support again. Okay, let's get started. Lifetimes. So here there will be a lot of writing, so we're going to talk about it. I'll be showing also some examples. And after we're going to go straight away into the break time before the hands-on. So be focused during this explanation. Lifetimes are a way to specify how long a reference is valid for. Rust has a powerful borrowing and ownership system, and lifetimes ensure that references are valid as long as they are needed or no longer, preventing issues like dangling references or use after free bugs. Rust does infer lifetimes in many cases automatically, but there are some scenarios where you need to specify them explicitly. So after here, we're going to go through different points in which you need to explicitly specify those lifetimes. So the first one is when lifetimes are automatically inferred. So just let's check this one first. Simple functions. When dealing with single references in functions, Rust often infers lifetimes, as it can determine the lifetime relationships from the function context. Basic structs. If a struct doesn't hold references, or if its references don't need a specific relationship, the compiler can often deduce the lifetimes. So when it's very simple, you don't need to specify those lifetimes. After, when you need to specify lifetimes, so when you have multiple references with relationships, if a function returns a reference that is derived from more than one parameter, like %r or %b, so if there is more than one reference, you need to specify which reference the output should borrow from. In this case, Rust requires manual lifetime notations to clearly define which parameter's lifetime is to be used. So Rust need to know which variable, because you're just using references and you're going to be returning something, and it needs to know which reference it's going to be leaving the longest, the shortest, so that it can deallocate those memory spaces. Another case where when you need to specify those lifetimes, structs holding references. If you have a struct that contains references, you need to specify the lifetimes to define how long the references within the struct should be valid. Without it, Rust can't infer the relationships between different fields on the struct as a whole. So while using struct, if you have several fields using references, which happens a lot, you need to specify the lifetimes. We might be using this example as a as a good and complex example and make it evolve in the hands-on part. Another reason to specify lifetimes, complex data interdependencies. So when functions involve complex borrowing or passing references between structs, the automatic inference may fall short, and the manual specification is needed to avoid ambiguity. So you see, when it's a very simple function, it's okay. Rust has an automatic process to infer those lifetimes, but when it starts to become complex, with a lot of structs, references, and references passing from one variable to another and so on, at this time you need to specify those lifetimes. Let's see just a few examples. So you're introduced to it. You can see the syntax, single lifetime versus multiple lifetimes. So single lifetimes, that's the notation here. So we have a single quote with a letter. This is just a placeholder, so you can put whatever you want here. So for example here, this function, this example function, has a lifetime A. It has a reference of an integer I32 with lifetime A also. X is a reference to an I32 with lifetime A. And here is going to return a reference of this integer 32 with the same lifetime. Okay, so this is very simple function. We might not need to use lifetimes, but it's just to show you how it is written, how is the syntax. So here, this notation, which is the single quote A, is a single lifetime assigned to both the function parameter x and the return type, meaning the return value is valid as long as x is. Okay, so x here is just living here for one line, but if there are multiple lines, it will be valid to the end of the function. Different lifetimes, for example here we have the same function, but we have two different lifetimes. We have A and the B, so that's the notation. You can say, for example here, you can put a name that is meaningful to you. X, here we have the same as we got here before, but we have the Y added, which here is a lifetime B. You see, and it's going to return A. So you can tell here that A has the longest lifetime, which is going to be just returning X here, even if you have this defined. It's not the best example ever, but we're going to go into the hands-on and you'll be able to see those. Here I try to not overcomplicate, because I'll be commenting and it will be more interactive. In this case, the return value has the lifetime of A, okay, regardless of B, indicating that the reference returned is tied to X lifetime. Okay, so here the function is going to be following along with the X lifetime. Lifetimes and structs. Here it was a function, and here we're going to see the struct. When a struct contains references, you need lifetimes to indicate how long those references are valid. Struct example, here we put a lifetime A, so because we have a reference in, we're going to use this lifetime to say how long it will be valid. Here, this notation, which is the single quote A, tells Rust that the field reference must have the same lifetime as A single quote A. Lifetimes in enums. So you can also use lifetime in enums. Lifetimes can also be used in enums when they hold references. So here enum, example enum, we have the same lifetime single quote A, and here the variant is a reference to a str, a string a string literal, and here we have the lifetime single quote A. So this means the enum variant holds a reference that must be valid for a given lifetime A. It's a bit of abstraction here using those letters of how long the variable will be available in the function. Okay, we're gonna see the scopes, different scope, to see how long variables are available, just to try to illustrate it in the hands-on part. Lifetimes on generics. You've seen generics, so we can talk about it a little bit now. You can combine lifetimes with generic types to create more flexible and reusable code. So here, function, generic function, we have a lifetime A, which is linked to the t-type. Okay, so the value of the function is a reference to the t-type, and the lifetime will be this notation with a single quote A, and the return value is also linked to this type, and the value is returned. This function works for any type t as long as value is valid for the lifetime A. We're not going to use generics to not overcomplicate the hands-on example, otherwise it's going to last too long, but we might see the structs. So the question I had, why use lifetimes? So to prevent dangling references, lifetimes prevent situation where you have a reference to data that has already been dropped, which can lead to undefined behaviors. So just to avoid those errors, memory safety without garbage collection. So Rust uses lifetimes as an alternative to garbage collection, making sure references are valid at compile time without a runtime performance hit. So this is part of Rust safety. Complex borrowing relationships. When dealing with more complex borrowing patterns, lifetimes allow you to, it allows us to explicitly define relationships between the lifetime of data and references, ensuring code correctness. What are those letters? A, B, and so on. The lifetimes label, so apostrophe A, B, or C, are just placeholders that you can use to represent the lifetime of a reference. And you can use any alphabetic letters or word to label them. So I had this question in my mind, is it meaning something to Rust? If I put an A, a B, or a C, is it different? So actually I got the answer that we can put anything. For example, A, B, X, Y, or even more descriptive names like name or data are valid. The only requirement is that they begin with an apostrophe. So here I said single quote, it's an apostrophe, so we're going to call it apostrophe. And follow Rust's naming conventions, just like variable names, lowercase letter are most common. Okay, so we are done with this explanation part. Not yet. So these are all valid. Just to show here, for the last slide, struct example A, reference %A, and here, for example, we're going to use a placeholder which is lifetime underscore name. So you can use it like that also. You can put a full word. Yet another example, input, output. Input, output. For example, you can put it like that for the lifetimes. The letters or words themselves are just symbolic, so they're just placeholders, and the serve has a way to specify relationships between the lifetimes of different references. So using meaningful names can sometimes make the code easier to understand, especially in complex scenarios. However, most people stick to short labels like A, B for conciseness, just to be concise and short. Okay, we're gonna stop here for the explanation part. We're done with that. And now we are gonna have a little break. Please like and subscribe. Okay, be ready with your terminal. We're gonna start by creating a file called Junko lifetimes.rs. So we are going to start with unique lifetime. So we're gonna start slow, and we're gonna go incrementally in our explanation to more, I don't want to say harder, but just more explanatory examples. And after, we will be going to explain some complex ones. Just playing with it. It's not hard. We're just going to be playing with the concept of scope, inner scope, outer scope, just to understand why we need lifetime, and more in between. But the hands-on is not going to be heavy, like the ones we did in some previous videos. Going to be heavy, so you can relax. If you made it to this video, you can handle all the different topics that we're gonna do from now on, because we've done the hardest ones already. So we're gonna create here a function, longest with lifetime. What we are going to do initially, we're just going to create the function as you know, as you've seen it. So without any lifetime, I'm just going to get rid of this. And after, I'm going to be introducing the syntax of the lifetime to it, so that you get familiar with it, familiarize yourself with it. So we have 2 points, just using the example, very close to what we've seen in the explanation part of the video. X and Y, their references. So you need lifetimes when you're playing with references, especially. And it's returning also a reference of an str, string literal. We're just going to check into which one is the longest. So the length, x.length, if it is bigger than y.length, we return x, else we return y. So this is just an easy function to understand. And here we can introduce the lifetimes. Just let me comment a bit. Let's introduce lifetimes to it, to this function. So to do that, we have the function name. The function name, we are going to add apostrophe A. So that's one lifetime for this function. And we're going to link it to, just going to push this here, to X, to Y. So when you do that and you put the same lifetime in all the variables that you pass into your function as a parameter, Rust is gonna stick to the shortest lifetime before dropping the values from the memory. So '(A) is here to make sure that's the shortest scope. Maybe I can say it like that, the shortest scope. Reference. Is how long this function will track references. Something like that. Let's close those comments to just see the function. I'm going to keep those for the moment. So for the return type also we need to add the lifetime, which is the same. We're going to close those comments. So this is very similar to what we've seen in the explanation part. Now I can create maybe a public function. Let's get some space. So let's call it lifetimes different scope. So we're gonna play with scopes just to understand what's going on in terms of lifetimes, or in terms of access to a reference of a variable and non-access. So when the variable is not available anymore, we are also going to use different scope just to show what is a scope, because we have just touched it a little bit, but we didn't talk about it. So lifetime is linked to scope. So we've seen different subjects. We were focused on those subjects only. We didn't want to go through the lifetimes at the same time, because I believe this could be just one unique video. That's why now we're doing that video. Explain why lifetimes are sometimes necessary. So using the scope concept, we are going to understand why we need those lifetimes. Rust automatically infers lifetimes. Okay, we're not using like crazy functions, but there are some limits to that. So here I'm using the syntax of lifetime for this easy function. We don't need it, but it's a good introduction to see the scopes and how it works. In the second example, I will use a struct at this time. Yes, you need lifetime at this time. It's mandatory to use it. Example, custom types using. So custom types, that's when I talk about enums or struct using those fields having references. So we need to know how long they're gonna live, those references, and we need to tell it to the compiler so it knows what to do with it. And the notation, apostrophe, letter or apostrophe, any word meaningful to you. That's the way the compiler is going to be able to track and know when to drop those references. So public lifetime different scope. We're going to create a string while variable. So string from, we're going to put when the problem happened, Naruto was displayed but no sound could be heard. Okay, we stay in the same kind of example in the manga Kisa. We're watching Naruto, but there's no sound. So here we got that. And now we're going to use those two curly braces that you see here. They're a bit special. Why? We are using double curly braces inside the function to create another, it's like a nested scope. Okay. Another inside scope. Inside the function. So outside of those curly braces, we are in the functions, let's say general scope. So this is a nested scope. Okay. So what we got here, it's a nested scope inside the function general scope. Which is implying different variables availability, especially if those are references. So we're gonna create a variable string2 in the inner scope, the nested one. We're gonna just create another string in. Very simple here. Let's try to put all in one page, like that. And here we're gonna say that there were no problem. No problem happened. Just the cabin. Okay, just leave it like that. 3 points. The result. Let's create another variable result where we are going to call the function that we have created. Longest lifetime. Which is going to take string 1. We call it string 1, but it's a string literal that we're going to get because we're going to use the method as underscore string. Okay, so it's going to become an ampersand str. As underscore string, it's a method that is by default available. Let's put all together like that. That's good. I can capture those typos. Okay, so here we have X and Y. The ampersand lifetime A string, X length. If it is bigger than Y length, we got X, and else we got Y. So that's how we can evaluate it. And the lifetime is an apostrophe A for everything. So here are the references. The compiler knows when to drop those references. We close those comments. Just check, because I always forget a comment or something. Here, it's here, we need the semicolon, and now we can print. We're going to print some variable. the longest string is. We use the normal formatting. Result. Okay. Let's print the other one. Here we are going to use the debug mode for string clone. Let's clone it. Okay. Lifetime, different scope. I'm going to just copy it. Okay, let's go now to the main.rs. We're going to import the module, which was named Junko __ lifetimes. And we're going to reuse it here. Now we have access to the function that we have copied. Junko _ lifetimes, different scope. And we're going to run cargo. What did we do again? Not a big deal. When you call a function, when you name a function, you have to put fn. We just put the pub. Let's go for fn function. So now we can cargo run it. We forgot one comment. Let's close this comment. Okay, now we can see the longest string is when the problem happened, Naruto was displayed, but no sound could be heard. And we got the other one also. No problem happens. So the longest string has been evaluated. Okay, so here the string has been evaluated. We got the answer. So in the inner scope, we have access to the outer scope variable. In the inner scope, we can print and clone also the inner scope variables. So that's what you have to keep in your mind here. We have defined string 1 in the general scope. Just after that, we have created an inner scope. Okay, and after we have printed the other variable, which has been also defined in the inner scope. So the inner scope here have access to what is above it, which is the general scope. Can play with it, use those references, for example, here in longest with lifetime function, do the evaluation, return it, all is good. If it has any variable defined in it, it can define it. Here I'm just customizing the prints. But that's what you have to keep in your mind here from this. That's the little learning from that. Okay. And now we are out of the scope, of the nested scope. We're back to the general scope of the function. So here I'm going to comment outside of the nested scope. And we are going to print. We're going to see, we need to print this one here. I'm just going to copy it. Get rid of that, paste it. And we got the string 2. Close the comment. So here we have defined string 2 inside the nested scope. And we are trying to print it outside of the nested scope after it in the general scope of the function, a local variable with similar name string1 exists, so that means that the string2 couldn't be printed out of the inner scope. So its lifetime has ended after we exited that inner scope. String1 is the only string that exists in the general scope because it has been defined in the general scope and hasn't been consumed. Because here we're just consuming the references of it, because we used the has _str. So we didn't consume the ownership of the function. We got an error. Okay, a local variable with similar name exists. String1. String2 is lifetime is linked to this, okay, to the inner scope, the inner nested scope that you have created, because string2 has been defined in the inner nested scope. Okay, so we can't access to it. So from here, it will be just out of the memory. It won't be anymore in the memory. When trying to print in the general function scope. Okay, this is part of the Rust safety. That's how it's gonna handle all the borrowing, the ownership, and all the different rules. But in the inner nested scope, for sure, we can play with it. We have access to it. Okay, we have access to it, and we have access also to the function's general scope, because string1 has been defined just above that. For example, here string1, which is here just borrowed, not consumed there. We use as _str. We haven't seen it before, so that's why I'm using it here. It's another way of borrowing a string, an owned string. We've seen ampersand. And this one here is just going to do the whole job. Okay, here we got it. We can comment this out, because it's going to create an error, now we know. Let's comment this out. And let's now print. Let me just copy this. Okay. Let's change this to string1. Okay, string1 still accessible. As only borrowed in the nested scope, so it hasn't been consumed in the nested scope, so we should be able to have it printed at the end. Yes, we got it. String1 still available as only borrowed in the nested scope. String2, and after whatever it's inside the scope is accessible, as we've shown it before. It's good. Here you get an example of inferred lifetimes. So this is very simple function. that we used. Also, without using the function, we've seen that just with the string one, the lifetimes are inferred automatically by Rust. And it's a good way for you to see the different scopes and understand how those references are going to be actually, those pointers are going to be dereferenced and the values deleted from the memory. That's how we provide new space. Okay. This was one example. Let's comment this example out. Okay, and here. Okay, nothing left up there. Now what we are going to do, we are going to create a new public function. We're entering the example 2, which is lifetime using structs. Structs, introduction, and more complexity with multi, just gonna do it straight, with multi lifetimes. Okay, we're gonna make sure that this struct needs lifetime, and we're gonna use several different ones, and we will be playing with it, this example 2, to the end of the video. So if you missed the first example, this one, you can't miss any bit of it, otherwise you won't be able to understand what's going on. So here we got our strict doctor. So the doctor has a name. So we're gonna just define everything as normal, as you already know it. And after we are going to introduce those syntax, lifetime syntax. Has a name, the doctor specialty, and the doctor hospital. We're going to do an implementation to doctor. That means we're going to create a function that doctor now can use, a method. So impl doctor, we use the function, we're going to call it print information. We don't need to overcomplicate it. It's going to take as a parameter the struct itself, so the reference of the struct, %self. Now we are going to print the different fields of the doctor struct. Doctor, specialty, okay, I'm going to see if I can use /n. I haven't tried it yet. If it works in Rust or not. So hospitality, specialty and hospital. And after we are going to call self on those fields. So you already know it now. You're an expert from now on. I mean, if you watched all the videos until now, you should be able to understand what's going on. Self name, self specialty, self hospital. We got that. That's not very different from our Python. So we have created struct with the implementation as normal. Okay. So everything here has been created as normal, but let's now transform it with different lifetimes. For each field. So you've seen the function before, we used apostrophe A for all different parameters to the function. While here we are going to use different placeholders. We're going to use apostrophe A, apostrophe B for doctors, and apostrophe C. So for each field, we're going to provide a different lifetime. Value with this apostrophe notation. Okay, instead of A, B, C, we could have put anything, any word, but we just use A, B, C. We don't need to have a complicated. And here, doctor and implementation also need this indication of a specification of lifetimes. Okay, now everything is set for the struct and the implementation. This is the right syntax. Now we can start playing with it, with those scopes. So we used scope in the first example. We're going to use scope here in the second example again, but having more explanations around it to understand those A, B, and C's step by step. So we have a public function, multiple lifetimes to struct. That's how we're going to call this first function. Let doctor name. So as you can see here, I'm just going to create a string literal, which is an str. Double quotes, you put your sentence, and that's a str. Doctor specialty. So the doctor name is Dr. Junko. Doctor specialty is cardiology in manga kisa only. Okay, so it's a special manga kisa where there is a doctor called Junko, and it's a cardiology doctor, and the doctor hospital. So there's no hospital in manga kisa, but he's from Shibuya General Hospital. So that's the context of our little scenario. Now, let's now create a doctor. So using the struct, we're going to do this instantiation. So we're going to create a doctor instance. Using those % strings. Fields. So those three variables are % strings, string literals. That's what I mean. The string literals. Not string, the big one here, string, no. Okay. So be careful with that. Okay, we get some space. We're gonna write more. Just let's create now the instantiation of this doctor. So let doctor, using the struct doctor definition, we're gonna now use those variables to define those fields, put some values to those fields. So the name, doctor name, the specialty, doctor specialty, the hospital, doctor hospital. So here we are doing those definitions in the general scope where doctor instance exists. Doctor, we're going to use now the implementation and just call it print info. So let me comment this like that here. So it will, or we expect to have all fields printed as here in the implementation, as you can see. So that's what we want now to do. Now you can guess what we are doing here. Nested scope. That's our little nested scope. So we are going to consume here specialty field, so println, we're going to put specialty, okay, and we're going to be saying doctor specialty, so here the $str will be consumed, so the reference is consumed by println macro. So be careful at everything I'm saying from here, yum. And after that, when we're gonna be able to print it, we're gonna come back here and talk more about what we've said before. Okay? It's a sort process. So we're going through my sort process and we're experiencing it to understand those lifetimes. Here we go. We're going to say another print outside of the nested scope after the inner scope. Okay. We're going to print ln again. Here, let's print hospital. Doctor, now accessing the instantiation of doctor. that you've created, doctor.hospital, hospital field. I'm just going to do some other prints. Let's copy and paste this. And now we're going to print also here specialty. Specialty. So here we print in two fields after the inner scope. Inside the inner scope, we print in just one field specialty, just to focus on this one. So we keep those for after. Okay, so what I'm going to do, this is just everything is prepared. I'm going to be commenting this part out. We're going to be printing first what is inside the inner scope. And after that, we're going to be printing everything with what we have printed at the end of the function, the outer scope, the outer nested scope. Okay, so we got a struct doctor having three different lifetimes, apostrophe A, B, and C for different fields, name, specialty, and hospital. In the implementation and the doctor, we have to indicate those existing lifetimes linked to those fields. Those fields are going to be printed in the implementation of the struct doctor, of the reference of the struct. Okay, we got those three variables which are going to be feeding those fields. Okay, Dr. Junko, cardiology, Shibuya Hospital. We instantiate the doctor struct. We use those variables. Okay, this is done. And we got our... Let me just change this. There is a typo. Specialty. Okay, all good. After that, we're gonna print, still in the general scope, the information, which should be printing all the fields of the struct. Okay. We expect to have all fields printed. That's what we've said. Nested scope. So now inside the nested scope, we are just going to access to one field, doctor specialty. We copy the function name. We go to the main.rs just to call this function now. We don't need this one anymore. Let's comment this out. Let's use the module Junko underscore lifetimes and call our function. There might be some issues as usual. We're going to fix it and call cargo run until it's fixed. Okay, today in my day of forgetting fn for function. So let's go back in quick and get this definition of the function multiple lifetimes to struct. Let's call cargo again. Now we're good. You see, we got access. Here is because we're not using longest with lifetime. We got a warning. And here we got access to all the feeds. We could print it everywhere. So that's what I was telling you. Be careful at what I'm saying there, because I said in the inner scope we were consuming the specialty field, the specialty variable, but we are not consuming it. It's a reference. This one here is not consumed. So from nested scope. Okay. put all in one page. And now we are going to print down there hospital and specialty. So try to guess what's going to happen before going to the terminal. After nested scope, and here also I'm going to put after nested scope, so that in the printed terminal we can just see clearly what is what. Okay, are we ready to go? Just check those lines, everything is saved. Let's clear the page, have a clear page. We print again, and you see we don't get any errors. We have access to those fields even after the nested scope. Were you expecting that? You see, specialty and specialty. We more focused into the specialty, and we see that we can have access to it everywhere in the function. Why is that? So we talked about the rule, about having a reference of a variable. You can have several references of that variable. Here we're going to be talking about lifetimes. The scope, it's accessible in the inner scope and the outer scope. So what's happened? Why did we get an error in the previous example? But here it works fine. So in the previous example there, when we did the example 1, we got an error doing that, trying to access to the variable, but it was a bit slightly different. In this example, everything works fine. Why? Println macro is consuming what? It's not consuming an owned variable. It's consuming a borrowed variable. Okay, so we said we use the term consuming, but the ownership hasn't changed. So we have still access to those variables. So the specialty field, as it's been defined in the general scope of the function, we have access to it, and we're using just references of it. So we can have as many references as we want. Okay, this one is hospital. And after we have here the specialty 1. So borrowed is borrowed. Okay. We're gonna go step by step into it. Now you've seen that when we define function in the general scope, you can have access to it in the nested scopes, especially if you use the reference of it. Therefore here it will print in the inner scope and also in the function general scope, as it is borrowed also. You have to keep this in mind. So whenever you create now your code logic, you have to think at different scopes and what is owned and what is borrowed. This is additional to what you already know. We got the ownership and borrowing rules, and now we're adding the lifetime rules to it. How long does a reference lives in a function? How do we indicate it to the compiler? Okay. Here in the first example, just to show you, I'm going to comment it on the top of this. The string 2 was defined inside the nested scope. That's why we couldn't access to it. And it was an owned variable. Owned string 2 variable. Okay. So I can close this example. Close. Okay, this is closed now. After owned, the previous example, the variable was owned. Let's close those comments. So I just want to take the, let's close this. I want to take the decorator, so we don't get this warning anymore. Let me close this comment. Cargo run here, this one. So we will have a clean print when there's no error. We say hello dead code. Okay. Now we can keep going. We can keep going down there. We're going to create a new public function. That's the last example. I create a new function. We're going to play with that function. Only this one to the end of the video. That's the last function, but it's going to be more explanatory for people who didn't understand how those lifetime works. So there will be here more comments. I'm going to use a single nested function like we did before. General scope, inner scope, nested one, and I'm going to do a nested of nested also. Double nesting. So that you can get the apostrophe A, apostrophe B, and apostrophe C. So we call this one multiple lifetimes to struct scope limited. So here I define just the name Dr. Junko in the general scope, and all the other fields are going to be defined inside the nested scope. We use the same terminology. The name is Dr. Junko, the specialty is cardiology, and the hospital is still the same, Shibuya General Hospital. Now we're going to instantiate our doctor and use all the fields. Now you know that we have access to the general scope fields. So here the name, we can use the name defined, the general scope. The inner scope has access to it, specialty and hospital. It's easier to write examples when you already know and seen those concepts. So Note that here, if we focus again on specialty, there's a little typo, so it's not with an E. So just to notify you that if you focus again on specialty field, it is only valid in the nested scope. Now you got it, because we have defined it in the nested scope. So hope that you got it, that from now you got it. Okay? So this message is transmitted when you define a variable in a scope like that. It's available and is alive, so its lifetime is linked to that inner scope. Out of this scope, the value doesn't exist anymore. The pointer is dereferenced. Okay? We're talking about ampersand STRs, so references, that what implies lifetimes. Indication to the compiler. We're going to print here with an indication of inside nested scope. The name. So the name is what has been defined initially in the general scope and used by the Doctor instantiation. And now we're going to take this name field from the Doctor instantiation and print it. We're still in the inner scope, so this is fine. We should be able to access to it. I'm just going to copy it twice and say this should be fine. There won't be any surprise here in this example. I'll be going straight. This also should be fine. I'm going to just use here specialty. Okay, Doctor specialty. So those two here, we know what to expect. We expect those two to be printed without any problem. Okay, let's close those comments. We go step by step. No rush. Let me comment this out also. I copy the function name. That's the one we're playing with now. I'm just going to put the decorator here because we're not using this function anymore, the one that we used just before this new public function. Allow that code. And now here we're going to use this one. Let's go to the main.rs to indicate that this function exists and that we want to call it. We're going to comment out what we've done before. Okay, this function is a allow the date code function, and here Junko underscore lifetimes, multiple lifetime to struct scope limited, and now we call it. Okay, as I told you, I'm in my day of forgetting the fn to define the function. So let's go and define this function as a public fn function. Let's clear this and call cargo. Okay, inside nested scope, Dr. Junko, specialty cardiology. So here we got what we expected to have. Very easy. No surprise. Now, we are going to start playing out of this nested scope. Now let's try to print again specialty. Let's focus on specialty. Okay, for the general function scope. So here, as you are an expert now, you should be able to guess what's going to happen. You should be able to guess after those examples. You'll be able to talk about lifetimes. Println and just say answer. This might create an error. That's the answer. Okay, but not this error. Let me fix this. I forgot to close the comment. So this might create an error, but not this one. Cargo run. Okay, we got our error. Not found in this scope. Let's copy this. Cannot find value doctor in this scope. So that's the error that we get. We were expecting it. Why? Can you answer? Because specialty has been defined in the nested scope. Doctor is being instantiated with that variable. The lifetime of that variable lives in the inner scope. Whenever we get out of it, value is deleted from the memory. The reference, the pointer is dereferenced. Okay? So that's what's going on. Okay, here, specialty. This is because it has been defined in the inner scope, the nested one. Okay, so everything is defined in the inner scope. So forget about accessing to it in the outer scope. It won't exist anymore. Even if it is a borrowed reference, it won't exist. Here, just forget about it. Specialty is a borrowed '(b) lifetime reference. So its life is in the nested scope. Out of the nested scope, we are in the general scope of the function. And it has been deallocated already. It's not in the memory anymore. So here we're using A, B, and C. So those apostrophe lifetimes. That means that the three fields are decoupled in terms of lifetimes. Because if we have used the same variable for the three fields, let's say if you have used only A 3 times, when the shortest scope, the variable is not existing anymore, all the other values would have been also dropped. They would be all linked together because they're all using the same lifetime. While here, when we're decoupling those lifetimes using A, B, and C, so here we say B, reference of an str. So we are able to use those variables independently, those fields, in a different scope. If one is dropped, the other ones are still existing, as long as they're still accessible in their scope, respective ones. Okay, so the memory is emptied of the value, doesn't exist anymore. When we exit this scope, for example, here, we have one field which is name, just the variable name, I mean. The field name is still inside the scope. So all the fields here are linked together implicitly because we put them all in the same scope. A nested one. So the inner scope can access to the name which has been defined at the top of the function, the general one, the general scope. But whenever we exceed this, it's not accessible anymore. Therefore here, the ampersand string is pointing to nothing. It has been dereferenced. It's not pointing anymore. There's no value behind it. Okay, that's how you can play with those lifetimes. Therefore, error in your face. So here we get just stopped by the compiler. Okay, it's telling us that this local variable doesn't exist anymore. A, B, C. That's how we decouple those lifetimes. If we put them all together in the same scope, they're going to just live in the same scope. But if there is one field which is shorter in lifetime than the other ones will be still able to exist because they have different lifetimes. So let's take here the example of A. Here is just a name, so we didn't. It's not still considered as a lifetime. So, but we know that we're going to use it in doctor struct. So here in doctor struct, it lives in, we have defined it. So here A is available, it still lives. So everything is fine. Okay. Here we're going to be printing it. So apostrophe A still lives, still available, as it has been defined in the initially it comes from the general scope, but here when we have defined the struct, we could allocate that variable in. But the lifetime has started when we have actually defined the doctor struct, because that's when we are decoupling those lifetimes. Decoupled from the two other defined inner scopes, inner nested one. But all of those now, because doctor is defined in this one, they're going to be all living in that scope. That's why I'm going to, in the next stage, create a second nested one, which is a nested of nested, so that you can see what's going to happen. Okay. Just going to get rid of this and go here and put it here at the end. Let me just copy this here. Okay, and we're going to try to outside of the nested scope. I'm going to comment out the one that we couldn't find, but for the name here, doctor name. So if we say doctor name, we won't be able to access to it, right? That's what we expect. See, that's a variable name, string literal. Here we instantiate doctor. We use that string literal in. Also here we can talk about this specialty apostrophe B. Lifetime starts. Okay. So it's gonna start when we instantiate this doctor. We have defined it inside, same for the C. So that's what's gonna become the B and the C when we're gonna put it inside the doctor struct. Okay, I'm just going to indicate what is the, so this is after the inner scope. Bye bye, doesn't exist anymore. Okay, A, I'm going to say even B and C. 5 times. Let's close those comments. Doctor.name, is it gonna print? It's not, for sure. Not found in this scope. Okay, so we have defined the doctor struct in the inner scope. So nothing out of that scope can access to it. Let's go down to find it. We are almost there in terms of explanation. We need just to add an extra nested function. I mean nested scope, just to reorganize this. So the name here you didn't guess right. Name is available, but okay, this is doctor name. Doctor name is not available because this one is from the nested one, not doctor name has doctor has been defined in the nested scope. Okay, this you got it now. You've seen it. Let's print. One more print. Let's make it clear. Name. Is still available. Just like that. Let's comment this out. We don't want to create any errors anymore. We want to show that the string name, yes, you see, Dr. Junko still available. Didn't put the space, but it works. Okay, let's make our double nested stuff so that we can see the A, B, and C, how we can say decoupled in terms of availability. We're gonna focus on doctor specialty maybe. Let's see. Here is the inner scope. So this is inside the nested scope. I'm creating another scope inside. So if you didn't get it yet, I will nest another scope inside the initially nested scope. Okay, this is a double nesting. Let's put this like that. And change the logic a bit. Let's close those, as we always forget to close the comments. I need to do some copy here. We copy this instantiation maybe of doctor. Here. Just take everything and I'll modify it accordingly. Last. Okay, I'll just put all indented as. And after I'm just gonna decouple here. I'm gonna be creating, those let specialty and hospital. I'm going to be separating the scope, so where they are created. One is going to be in the double nested scope, while the other one is going to be in the first nested scope. Leaving there. Let's get rid of this. Okay, we get rid of all this. Okay, we don't need that. Let's get rid of the comments here. Okay, so we have everything that we had before. Now it's living in the double nested scope. I'm going to extract one of those values and put it outside. Specialty cardiology, hospital, let's put hospital here. We can get rid of it. So the doctor, which is in the double nested scope, has access to the name, to the hospital and the specialty. Everything is fine because this waterfall of scopes is still inside. So for the lifetime, you have access to all of those. They're all living at his level. Okay, that's where you can see the decoupling of the A, B, and C. Apostrophe A, B, apostrophe A, apostrophe B, apostrophe C. That's how you can see how they're decoupled. Here, I'm going to focus on specialty. I'm going to try to print it inside the nested scope. So the first level, not the double level, the double nested one. So I might need to indicate where does it stops. So this is inside nested 2. Okay, inside nested 1. The nested 2 is the most deeper nested scope. Let's put this in. hospital. Here, hospital. So the variable name is general scope, first level nested scope, hospital is defined, so we have access to it. Here, it's okay, it's going to be fine. This is the end. So this is the end of the nested 1 scope, and here we got the end of the nested 2, which is the deeper nested scope, double 1. Okay, specialty is in the deeper nested scope. Doctor has been instantiated inside of it, has access to all those fields because the lifetimes, they're still alive. We don't have those pointers dereferenced. Okay, so this one should be okay. Here we can print this. We can have access to doctor name. We can have access to this. Those variables at the end of the nested 2, we have access to hospital. So this one should be okay as well. So here, no surprise, I'll just tell you straight. Okay, because hospital is in the same scope, so we can access to it. Hasn't been consumed at all, because we're playing with references. Because available in same scope. Okay. So you need to play with it a little bit more. You can try to print hospital in the double nested also. There's a different combination that you can try. And read what the compiler says, if there's any error. Here is the problem with this one. Has its lifetime, will die. Okay, his lifetime is dead, doesn't exist anymore here. So after the nested 2 is out of scope, the value doesn't exist in the memory, the pointer is dereferenced. So Rust safety has worked, and the decoupling of those lifetimes has worked also. So here we're mixing the lifetime that you have created and the ones that are automatically inferred by Rust. Okay, so we're focusing more into those now. So here we expect to get an error from this one. We comment it out. We're gonna do in 2 steps. Then we check it. Okay. Let's do the multiple line comment here, and we close this here, and we go to cargo to check that. Let's clean this screen. Run. Inside nested 2, Dr. Junko, and the other one, the hospital is available. And now let's try to get the instantiated doctor and the field specialty by commenting out this one here. I tell you after that you'll be expert in lifetimes. Here we go. You know what's going to happen. Not found in this scope. Okay. As expected. the reference doesn't exist anymore. There are some typos, but I'm not gonna pass on it. It's okay. You understand what I mean. Bye bye. Congratulations. You arrived to the end of this hands-on part. I think now your brain is ready for lifetimes. You understand what we talk about when we talk about lifetimes. Here we go. Everything works fine. We have seen how different scopes are linked to variables availability in the code. When using references, there is an out-of-scope dereferencing, making the variable disappear from the memory and die. This is called lifetimes. Some are inferred by Rust automatically. Some others, in custom types, for example, structs, like we have seen here, need to be indicated. So we need to specify those for the compiler to know how long it's going to be able to use those references and how they are linked between each others. We tell how long is the references available using lifetime notation with the single quote, and we add the placeholder letter, or it can be a word, full word that is meaningful to you. Lifetimes is to prevent dangling references, meaning reference pointing to no values behind the scene. I encourage you to keep going. We have few topics left to the end of this amazing Rust playlist. We stop here. Hope that you liked this video. Thanks for the support again. Please like and subscribe, and see you next time for another Have a Break, Have a Rest session.